we did this. We started with organic, and we started doing these things. We started talking about formulas, like how do you write organic formulas, and I told you that there's the first version, which is a fully displayed formula. I mean, they're known as structural formulas. Any formula that provides information about the structure of a molecule, that's a structural formula. So the first one is a fully displayed formula that every atom and bond is shown, and in that you need to remember this thing, that which group normally makes how many bonds. Group 4 makes 4 bonds, 5 makes 3 bonds, 6 makes 2 bonds, and 7 makes 1 bond. So we did that. So whenever you draw a structure, the atoms should be making the right number of bonds. So you've got carbon making 4 bonds. Fluorine is in group 7. It's supposed to make just 1 bond. Oxygen is in group 6. So that is going to make 2 bonds. And you've got sulfur, the group 6, that's making 2 bonds. So every atom must be making the right number of bonds. That's the first thing. And that's a fully displayed formula. And then we started talking about the condensed structural formulas. And in those condensed structural formulas, what you have is that this is a molecule. Every atom is making the right number of bonds. Carbon is making 4 bonds, 4 bonds, 4 bonds. Nitrogen is in group 5, so it's supposed to make 3 bonds. So everyone is making the right number of bonds. The condensed formula is that you just start writing what's next to the carbon atom. There's a carbon atom with 3 hydrogens, so you call it CH3. There's a carbon with NH, so that's CH. Anything that's sticking out of the chain, that would be put in brackets. So it's CH and OH. Then you have another C with H, and there's a CH3 branch. So you have another C with H and a CH3 branch. Then there's a CO. Then there's another CH with an NH2. So CH, and in brackets you have NH2. And then you've got a CH3 again. So that is something that we did, and we're going to keep on practicing this. And the third thing that we did was we talked about skeletal formulas. So skeletal formulas were that what you do in skeletal formulas is, like over here, if I have this molecule, what you do in a skeletal formula is, and we're going to practice that as well, that you don't show any bonds. What you just show is that you draw these 3 points. The points represent carbon atoms, 1, 2, and 3. So it's 1 carbon atom, 2 carbon atom, and 3 carbon atoms. So that's, you just draw zigzag lines. So that would be this thing. Okay, that's a skeletal formula. You've got hexane over here. That's 6 carbon atoms. So that's 1 carbon atom, 2, 3, 4, 5, and 6. So these points are your carbon atoms, and the lines represent the bonds that are between them. So we're going to keep on doing this, TK. We're going to keep on discussing these 3 types of formulas, TK. You'll get this. So we did the naming of the first type of homologous series, which is alkanes. So you had alkanes. These were saturated hydrocarbons. That means they were all single bonds, carbon and hydrogen atoms. Remember the counting, it's meth, eth, prop. Bute means 4 carbon atoms, pent is 5, 6 carbon atoms, 7, 8, and non and dec. So we were just doing the naming of simple molecules, straight chains that only have 1 functional group, that's it. So starting and continuing with this, the next one is...
So you see with the skeletal thing, how you do the dots, don't you draw the H's with it?
No, you don't show the H's. The only thing that you show is, you don't show the H's. The only thing that you show is any other thing that's bonded to it, any functional group. For example, 1 carbon atom, you don't show the H's. 1 carbon atom, 2 carbon atom, and then there's 2 carbon atoms connected to it. So this thing would be represented like this. It's 1 carbon atom, 1 dot, second one. Then from the second one, there are 2 carbon atoms coming out of it. So that's 1 on top and 1 over here. Hani, is this clear up till this point?
Yes, thank you.
And then you've got the oxygen, you show the oxygens. Like any other thing, you do show that. Like the OH and the NH2 and any other thing apart from the carbon and hydrogens, you do show that. So oxygen followed by another carbon atom, that's a dot. That has a double bond O. So you show that. Then you've got 1, 2, 3 carbon atoms. So that's 1, 2, and 3. Between these two carbon atoms, there's a double bond. So between these two dots, there's a double bond. You show that. On the third carbon atom from the left, there are two functional groups. One is OH and the other one is NH2. So you show those OH and NH2 groups as well. Achha, but you'll get it. We'll keep on practicing this. So the next one is alkenes. And remember, we're going to focus on simple alkenes. So alkenes, what are alkenes? Now they are known as unsaturated hydrocarbons. What that means is that unsaturated means that the carbons and the carbons will have a double bond, at least one. So there's going to be at least one, and that's your functional group. Plus it's a hydrocarbon, so that means it's only going to be carbon and hydrogen atoms. So here's an alkene, like you have 3 carbon atoms. Here's another one. Let's put a double bond here. This one will have 3 H's. This one will have 1 H, 1 H, no H actually. That already has 4 carbon atoms. This one will have 3 H's. And this one will have 3 H's as well. This carbon atom over here is already making 4 bonds. So that's done. I can write the condensed version of this, which is going to be the first carbon atom. I mean, you just move from left to right. Okay, just keep moving from left to right. When you do that, the first carbon atom over here is C with 3 H's, so that's CH3. The next carbon atom is C, and there's a branch now that's sticking out of it. So that's C with CH3. And then you can choose to show the double bond or not. I mean, there is a double bond after that. So there's this double bond. Then you have another carbon with an H followed by a CH3. So that's the condensed version of the molecule. And we can draw the skeletal formula as well. So that's 1, 2, 3, 4 carbon atoms in a row. So that's 1, 2, 3, and that's 4. And on the second one, there's another carbon atom that's coming out of it. So that's so on the second one over here, there's going to be another carbon atom. I'm going to show it with another color. So that's another carbon atom on the second one. And between these two carbon atoms, there's a double bond. So I'm going to put a double bond there. So that's the skeletal version of this. Okay? So I'm just going to go over this again. That is 1, 2, 3, 4 carbon atoms. 1, 2 dot, 3 dot, 4 dot, 4 carbon atoms. Second and third, there's a double bond, which is over here. And on the second one, there's another branch of carbon atom that's coming out of it. So I'm going to put this branch over here. So is this clear? Okay, everyone, is this clear?
Yes, sir.
Yes, sir.
Achha, so that's an alkene. Now naming alkenes, it's the same way. You've got a prefix, which is going to be the same one, number of carbon atoms. So you're going to have your prefix and you will have your suffix. So you've got a prefix and you've got a suffix. The prefix is the same thing. It's meth, eth, prop, etc. And the suffix is going to be ene. So for example, I have this molecule, just 2 carbon atoms. There's a double bond in there. And I'm going to call that molecule. What's the name of this molecule? 2 carbon atoms is
Ethene.
eth, followed by ene. I mean, there's not going to be any dash, but it's prefix and suffix. Similarly, you'll have 3 carbon atoms. There's 3 carbon atoms would be and this will have 3 H's. So the name of 3 carbon atoms, that's going to start with prop, followed by ene. So it's propene. When you reach 4 carbon atoms, you have to do something, and that is that the double bond must be numbered. You have to tell, I mean, up till 3 carbon atoms, it doesn't really matter because the position doesn't really matter if you have 3 carbon atoms or you've got 2 carbon atoms. So, but after that, the double bond has to be numbered. You've got 4 carbon atoms, so it's going to be so this is 3 H's, this would be 1 H, this one will have 1 H, and this one will have 3 H's. So this one is but, and the functional group is ene, but you have to number it, and numbering is done from the side that gives a smaller number. So you're going to number it from the side that gives smaller numbers. So in this case, this is going to be 1 and 2. So it's going to be but 2 ene. The position is mentioned before the ene. So that's our position. Here's another molecule. I've got I've got 6 carbon atoms. There's a double bond here. This is 3 H's. 1 H with this one, 2 H's, 2 H's, and this would be 3 H's. So what's the name for this one? Anyone? Take it just a second. Can anyone else? Is my voice breaking up or is it fine?
Green.
Okay, so this is hex, and there's a double bond. It's ene. You have to mention where the double bond is. What's the position? So you can count it from this side or that side. So you're going to count it from this side. It's going to be 1 and 2. So it's going to be hex 2 ene, because if you count it from this side, it's going to come out to be 4. So that would be not, I mean, that would be a bigger number. So this would be hex 2 ene. So is this clear?
Yes, sir.
Okay, or is my voice fine? Is it breaking up or not?
It's fine.
Okay. So that's hex 2 ene. Sometimes what would happen is you'll have multiple double bonds. So the next one is if you have multiple double bonds. Now again, let's say I've got a 5 carbon atom molecule, and I've got a double bond here and I've got a double bond here. The first one will have 2 hydrogens. This one will have 1 H. This one will have 1 H as well. 1 H, 3 H's. So this one is pent, and it's obviously ene. But in this case, there are 2 double bonds. So you're going to write diene now. You're going to call it a diene. And you're going to give the position for both of them. Remember, counting counting is going to be done from this side. This is the first double bond is at 1. Then you've got a double bond at the third one. So it's going to be 1, 3 diene. So you're going to mention both of them. Di means that you've got 2 double bonds now. And one of them is at 1 and the other one is at 3. If you count from the other side, it's going to give you bigger numbers. So don't count it from the other side. Choose the side that gives you, and both of them would be counted from the same side. Everything would be done from the same side. Once you pick a side, everything has to be counted from that particular side. So this one is pent 1, 3 diene. So that's multiple functional groups. If you have 2 double bonds. Okay, is this clear?
Yes, sir.
As a plus, you've got to know one more thing, and that is when you're writing the name, when you have 2 numbers together, there's going to be a comma between them. And when you have a number next to a letter, there's going to be a dash between them. Okay, so you have to follow this. I mean, this is just a tiny point. Like I wrote 1 and 3, there's going to be a comma between them. Between the 3 and the D, there's going to be a dash. Number and letter, that's going to be a dash. Number and number together, they're going to be separated by a comma. Achha, so that's pent-1,3-diene. Let's move to the next one. Let's talk about alcohols now. Now, when you talk about alcohols, alcohols have this functional group. They're going to have a carbon chain, alkyl chain. That's your carbon chain. Plus, there's going to be an OH group that would be attached. And remember, it's the O that's always going to be attached to it. The general formula is CnH2n plus 1 and OH. And the suffix in this case is an all. The name ends with all. So here are a few molecules. You've got, so remember, whenever you draw an alcohol, connect the O. Even if it's on this side, it's the O that's going to get connected. If it's on this side, it's the O that's going to get connected. So this is an example of an alcohol. Like you can have 3 OH groups, 1 OH groups, whatever. So these are your alcohols. So here are your two molecules. I'm going to do these 3. So I've got an OH. This one will have 3 H's. This one will have 1 H and 3 H's. So let's start with this one. What would you call this? What would be? It's just got 1 carbon atom. What would be the name of this?
Methanol.
Okay, so that is meth. There's AN and then there's OL. OL indicates that it's an alcohol. The AN this is going to appear every time. The AN tells us whether it's saturated or whether it's unsaturated. I mean, in this case, it is saturated. That means all bonds are single bonds. So it's a methanol molecule. What is this one? This would be 3 carbon atoms. So it's going to be a propane nol molecule. But you have to mention which carbon atom is the OH bonded to. So it's on the, you can count from this side or that side. Doesn't really matter. Both sides, it's on the 2nd carbon atom. So this one is propane 2-ol. Is this clear?
Yes, sir.
Okay, Hania, is this clear? Is that clear?
Yes, sir.
Yes, sir.
So remember, the formula is the same, just like alkenes. Suffix that represents the functional group. You tell the position of the functional group if that is required. I said, what would you call this one? 2 carbon atoms. So it's going to start with eth, and then what? It's going to be An because it's saturated. I mean, all bonds are single bonds, and then there is all, but there are 3 of them. So if you've got 3 of them, that means it's a triol. Right? That means there are 3 of them. So the OH groups are 3. And you have to mention the position of each one of them. Like, where are they? So the first 2 on the 1, I mean, this one is at 1, this one is at 1, this one is on the 2nd one. So it's going to be 1, 1, 2, triol. So this one is a triol. It's got 3 OH groups. So triol indicates that there are 3 alcohols. 1 over here, 1 over here, 1 over here. 2 are on the first one, 1 is on the 2nd one. Let's do another molecule similar to this one. Okay, in this case, what we can have is here's an OH, here's an OH. The rest is hydrogens, 2 hydrogens with this one, 2 hydrogens with this one, 1 H with this one, and 3 H's with this one. First thing, it's going to be called bute because it's got 4 carbon atoms, and it is saturated, so it would stay AN. Butanol. OL indicates that there's OH groups, but there are 2 of them. So if there are 2 of them, you're going to call this diol, okay, because you've got 2 OH groups. What are the positions? You can count from this side or you can count from the other side. If you count from this side, that gives you the smaller number. This would be 1, 2, this one is at 3. So you got 1 at 1 and you got 1 at 3. So it's going to be butane 1,3 diol. Is this clear?
Yeah.
Okay, so I'm just going to break this up once more. So what does each thing indicate? That indicates number of carbon atoms. The first part. AN indicates saturated. That means all bonds are single bonds in the carbon chain. All indicates alcohol. Di indicates the number of functional groups. And before that, the number indicates the position of those functional groups. Okay, so here's a breakup. It's going to be starting with the carbon atoms. Alcohol, AN is always there. Remember, AN would always be there. The position of the functional groups, if there's 1, just keep it all. If there's 2, make it diol, make it triol, tetraol, depending on how many functional groups you've got. Okay, is this clear to everyone? Alicia, clear? Abdullah, is this clear?
Yes, sir.
Yes, sir.
So now, the next one is, I'm going to make it slightly more difficult. I'm going to put in a double bond now. So let's say I have this molecule now. I've got this one. 4 carbon atoms. I've got an OH here. I've got an OH here. And I've got a double bond as well. This one will have 1 H. And there will be 3 H's with this one. So now it's an alcohol with a double bond. So that means it's an unsaturated alcohol. You've got a double bond now. So what would happen to the name? It's 4 carbon atoms, so that's bute. AN oil. First thing, it's got a double bond, it's unsaturated. So the AN will change into EN. Is this clear? Is this clear? It's no longer an alkane, it's an alkene now because there's a double bond. Is this clear?
Yes, sir.
Okay, so the AN has changed into EN, just like alkane changes into alkene. And it's all, and there are 2 of them. So that automatically indicates it's going to be a diol. So then you have a diol. What are the positions of the diol? I'm going to count from this side, smaller numbers. So that's 1 and 2. So it's 1 and 2 diol. And I'm going to rub off, get this here. Plus it's EN. Now, if it's EN, you have to mention the position of the double bond as well. Now you're counting from this side, so the double bond is at carbon number 2 as well. So you got to mention where the double bond is. So the EN is at 2. I mean, the double bond is at 2. The double bond indicated, I mean, this indicated that there was a double bond. So that's your EN. So this is but2-ene 1,2 diol. Is this clear? This one. Yes or no? Is
Yes,
this,
sir.
Mayam, is this clear? Aisha, is this clear? Anna?
Yes, sir.
Yes, sir.
Achha, so now remember the whole, I mean, the structure of the naming is going to be exactly the same. Starting number of carbon atoms, number of functional groups. So that's, it's going to end with all. In the middle, there's going to be AN or EN. So depending if the carbon atoms have double bonds in there, so this is going to be EN, and how many functional groups that would be represented by diol or triol. You have to give the positions of those functional groups. You have to give the position of the double bond as well. So that's the molecule over here. So we're going to move to the next one now. You get the same structure. The only thing is that the last ending name or the suffix would change. That's it. So the next one is, the next one is, let's do carbonyl compounds. We can do carboxylic acids as well. Let's do carboxylic acids. So now carboxylic acids are easy. Why? Because carboxylic acids have this functional group, C double bond O and OH. If you condense it, it's all often written as RCOH. Sometimes it's even more condensed and written as RCO2H. So all of it is the same thing. Now, this one is always going to be position number 1. So that means you don't have to give it a position because it's always position 1. Remember, carboxylic acid, whenever you see a carboxylic acid, that carbon is position number 1. For example, if I have this molecule and there's a double bond O and OH and 2 hydrogens, and there are 2 hydrogens with this, and there are 3 hydrogen with this one. This one would be but, and let me write down the suffix. It's going to be, the suffix is oic acid. That's going to be your suffix. You're going to add the AN or EN, depending on what it is, and it would be oic acid. No need to give the position. This is number 1. This is carbon number 1 by default, always. So you don't have to give the position of the carboxylic acid group. It's never going to come in the middle in the first place. It's always attached right at the end, or at the start, which kind of is the same thing. So let's do another one. Let's do butanoic acid, double bond O, OH, except now you've got a double bond over here. So that's 2 H's with this. There's going to be 1 H with this, 2 H's with this one. So the only difference now is it's again but. It should have been AN, oic acid, except it's no longer saturated. It is unsaturated. That means instead of AN, this has got to be an EN now, right? Is this clear? Because of the double bond over here. Clear? Yes or no?
Yes.
Yes, sir.
And you have to give the position of the double bond. Now you're not going to count from this side. Remember, I told you that the carboxylic acid is position number 1. So it's 1, 2, double bond is at position number 3. So it's going to be but 3. So you have to mention where that double bond is. So it's but 3 butanoic acid or but 3 enoic acid. So that's the name. Instead of butanoic acid, this is butanoic acid. The AN has changed into EN. So in this case, the position is not an issue. But what you could have is you could have 2 carboxylic acids in a molecule. What you could have is so you could have a molecule with two carboxylic acid groups. This would have two hydrogens. This would have, so I've got two carboxylic acid groups now. So it's 3 carbon atoms. So that's prop. It is saturated, so it's going to be AN. It's a carboxylic acid, so it's oic acid, except that there are 2 of them now. So it's going to be dioic acid. You don't need to mention the position because by default, it's understood that they are going to be at the end. You can't have a carboxylic acid functional group in the middle. That's not going to be possible. Okay. So is this clear?
Yes, sir.
Yes, sir.
Okay, so this one is kind of easy because you don't have to number the carboxylic acid most of the time. The next one we're going to do is we're going to do aldehydes and ketones. So we're going to start with carbonyl compounds. There are 2 types of carbonyl compounds which are new. I mean, they were not studied in AS, in O level, sorry. Carbonyl compounds are compounds that only have serial bond O. So if it's right at the end, that's an aldehyde. If the double bond O is right at the end. So that's what an aldehyde is. And the suffix is Al. That's the suffix. So for example, I've got this molecule. This is 2 H's, 2 H's, 3 H's. Again, counting is always done from the aldehyde part. So you don't have to give it position because it's always going to come out to be number 1. So this is bute. En because it's saturated, and it's an aldehyde, so it's going to be al. So it's butanol. Similarly, so this is butanol. Now, similarly, you will have another one, which is, let's do another one. I'm going to add a double bond here. So I'm going to add a double bond here. This is double bond O and H. This will have 1 H, 2 H's. So in this case, the counting is always done from the aldehyde part as well, because it's closest to it. So this is propanol, except instead of AN, it's going to be EN, and it's going to be al. And you have to give the position of the EN. Where's the double bond? Like which carbon atom? So it's this one is number 1. This would be number 2. So it's on the number 2 carbon atom. So that's the name of the molecule. Is this clear?
Yes, sir.
Yes, sir.
And so any aldehyde, it's going to be named in exactly the same way. It's going to end with al. Okay, that's going to be our suffix. Okay, the starting part. And in the middle, it's going to be AN and EN. You have to decide whether it's saturated or unsaturated. And similarly, you have another one, which is ketones. So we're going to quickly do ketones. Ketones is the second part of this, of carbonyl compounds. Now in ketones, what happens is that the double bond O is right in the middle of the chain. Now, if it's in the middle, you have to give it position. In aldehydes, the position doesn't really matter, because it's always at the end. Like if you just call it al, if something ends with ethanol, butanol, propanol, you just understood that the double bond O is right at the end. So you don't have to give it position. So in ketones, it's not at the end, it's somewhere in the middle. So now you have to give it a position. The ketone suffix is ONE. So the double bond is going to be somewhere in the middle. So 3 H's, you got 2 H's with this one, and you got 3 H's. So that's 5 carbon atoms. So that's pent. If it's saturated, there's going to be AN, and it's going to be ON. And you have to give it the smaller number. So this would be 1, this would be 2. So it's pentan to ON. Okay, so the same way, only the suffix has changed. The N part has changed. The AN, that's the number of carbon atoms. That's AN or EN, whether it's saturated or unsaturated. And the suffix has changed. So that's pentan to ON. What about this one? I've got a molecule. There's a double bond O here and a double bond O over here as well. Now this is 2 ketones. So it's 4 carbon atoms, that's bute. And AN, because it's still saturated, and you've got ONE, but you've got 2 of them, so it's going to be di. And you have to give the position, so it's going to be, I mean, you can count from either side, doesn't really matter in this case. So this would be at 2, this would be at 3. So it's going to be 2, 3. Di-on. So that means it's butanone, but 2 ons, that means dione, and 2, 3 dione. That's the position of the 2 ketones over here. Is this clear as well?
Yes, sir. Yes, sir.
So we've done a bunch of molecules. I'm just going to give you an assignment for this to name this. And remember, these are simple at the moment. These are simple straight chain molecules with just one functional group. That's it. So try and name all these compounds that I'm writing. So I've got an OH and I've got a double bond here. I'm just going to draw, I mean, these are H's. Okay, the dashes I'm putting, those are your hydrogens. Try and name all of them. These are your hydrogens. So these 4 molecules, try and name this. I'm posting this as an assignment. Remember, the dashes are just hydrogens, so just take a snapshot. Okay. Today, let's continue tomorrow. Try and do these, submit these. Okay, then we're going to do more complicated naming. The next thing that we're going to do is, if the same molecule has multiple functional groups and it's got branches as well. We haven't done branching and we haven't done multiple functional groups. Like you have an alcohol, an aldehyde, a ketone, and a carboxylic acid all in the same molecule. So how would you name that? So let's continue with this tomorrow now. Okay, I'm posting the assignment. Okay, everyone.
Allah Hafiz. Thank you,
Take care.
sir. Allah Hafiz.
Hafiz.
Thank you, Allah.